Okay, so we have today Peter Lawrey and Cyrille. A few words about Peter. So he's a real technical guy on Java. He created basically a framework called Chronicle, which is open source and it's used by a lot of the banking sector, right? And provide real-time support for small data, managing data in real time. And I think Cyrille, you're the authority, so he's the guy with the big data. Right?
I'm a faker, by the way. I'm not the guy making it happen. Okay, I can just talk about it. The guys who can make it happen are here if you want to ask any questions. Okay, thank you to those guys.
That's good. And I don't know. Let's start. Maybe we can start with Peter. Maybe if you want to say a few more words about yourself.
Yeah, sure. Yeah, so my name is Peter Lawrey. I've been working with investment banks and hedge funds for about 10 years and about 24 years in IT in total. I'm a Java champion. I have the most answers for Java in the JVM, memory, and file I/O and Stack Overflow in the world.
You're on the first place now?
Sorry?
You're on the first place?
Well, they have an interesting ranking system, which I can discuss it later. But, in terms of number of questions answered, I have the most. If you look at as a side note, if you look at the JVM, you look at 5 of the top 20 ranked people for the JVM have only ever answered one question, ever, in anything that they mentioned. So they have an interesting ranking system. So, what else? I have a blog, Vanilla Java. It's got 300 articles and about 4 million views. And last week I got 11,000 views on Quora.
Okay, which was also topic not necessarily technical, right?
Yes. So some of them are career advice. So I found some of the other discussions interesting. I do sometimes answer questions on career advice, not just purely technical type questions. So I'm sort of interested in a range of different things.
Okay, so one question for both, basically. How do you see, I mean, from a Java perspective, you are really working real low level, right? How do you see this compared with software as a service and the cloud and the big data? How do you see this, working together for a company? I mean, like having a your own solution, real, high performance compared with high scaling, but, maybe, I don't know, how do you guys see the cons and benefits of that?
I would probably just come back to one of the learnings we got from one of the mistakes we did. Everything you can have as a service, just use it, and it's a no-brainer to me today. If you have, should you have asked the same question probably 1 year ago, I would probably have said the opposite. Like it's very important to just stay in control of its entire stack, of your entire stack and so on, not rely on third-party everything as a service or whatever. We have wasted so much time just trying to make software run and just not work on interesting stuff for the business. Now I would say, really, if there's something as a service out there, just use it for your needs and just don't try to use the stack by yourself. I don't know if it.
Yeah, so we do some very low-level stuff, but we also advocate the use of services. It's a matter of making sure that the service is at the right level of granularity. So if you've got a really simple operation, it probably shouldn't be a service. But you build up a simple operation, you have a series of operations, you make it something a bit more complex or something that's more versatile and useful, at that point it starts to make sense to make it a service. And some of this reflects both the technical aspects, but also organizational aspects. You can make it that anything that you want to share between teams probably should be a service. And so to some degree your organizational structure will determine how you divide up pieces of work. You may make it that each piece of work that an individual developer works on is a service. And then that the interaction between what developers are working on are all service-based. So that there's a combination there, but it is a reasonably high-level operation, and by doing so, you avoid some of the efficiency issues that you can have with a service. If you break it down too much, you're doing too many service calls, then you get performance issues and you get other complexity problems. But if you break up services at the right level, either to make your teams more productive, so you're dividing it up by people, or you're making your machines more productive, so you're actually then dividing it up by hardware arrangement. So it's a different requirement. So if you've got many more machines than you do people, you're starting to think about, well, how can I make use of these machines most efficiently? If you've got, like your budget in particular for developers is higher than your budget for hardware, you're probably thinking more about, well, how can I be the most productive with my people? And so services can really be an important element of that, because you're improving the efficiency of each developer and the scalability of those developers as well to work with each other.
Okay, so basically, the next question will be, based on what you just described, how you guys see the use of microservices. I mean, goes well with the services, and you can integrate them well, this architecture to have them scaling.
I'm not sure I'm very legit to answer that question, but I can describe what I see actually the guys are doing in the Paris team, in the data team. There has been in the past 3-4 months, I mean, most of the effort on the infrastructure level was to implement a Mesos cluster, just so we could actually run, I think we have probably 40 to 50 microservices, names at least, don't know the number of instances. So we just reached a level where those microservices could not be administrated very easily with like a common framework and so on. Hence the switch to something that I'm saying is is decoupling the link between hardware and the services themselves. What I see is just the premise that the administration of those microservices would be probably easier. I see also it comes from with a lot of struggles, because it's not that easy and that out of the box to implement that kind of architecture today. Don't know if it's a question of maturity of us or the maturity of this, like the frameworks themselves. Okay, I would probably bet for the first one, because I'm not sure. I mean, we are quite new to that. Now, I mean, what it seems is like microservices have, I mean it's been quite a buzzword in the past 12 or 14, 28 to 24 months. I would actually turn to you to ask if it's something that you think is actually for steady. I mean, if there's a steady trend on that.
I would say that there is. Part of the benefit of part of what's been happening is trying to work out even what microservices are. And previously we had service-oriented architecture, and that's been around for quite some time, about 10 years. The problem with service-oriented architecture is that it got fairly bloated and added a lot of complex products that tended to be vendor-based. So you see a lot of J2E in there, for example. And in general, a lot of these services don't need to be that complicated. And microservices is partly an attempt to cut it back to what are the best practices, what are the most essential elements and functionality that's required. And to some degree, that it started with just trying to get common language around these things, talking about orchestration, instrumentation, service discovery, and what are all the basic pieces of functionality that these microservices need. And it was a buzzword, and to some degree buzzwords are useful because then you can at least get some common terminology. It also had a lot of overlap with what people were already doing in many cases. So some people found that they just went through a rebranding exercise and say, well, how does it fit within the microservice technology terminal space? And then you start to see, well, actually there's some minor improvements we can make. We can make some quick wins without changing anything dramatically. And then after they're brought into microservices for a period of time, and they start to see the benefits of it, then they can start looking at some wholesale changes, and maybe not changing everything, but there are many different aspects to microservices. And one of them is orchestration. How do we roll out our services? And so you might decide, well, that's the bit, that's our pain point. That's the bit where we start to say, well, where is there some standard functionality that does this for us? And Resources is a widely used one. So not necessarily, the most important thing with adopting microservices is don't look to change everything at once. I've seen a lot of projects fail because they went straight from monolith to let's do everything microservice. And the learning curve is just too steep. And there's so many things go wrong. And you only have so much sort of time budget and resource budget to make these migrations. And if you start to exceed that budget because there's just too many issues that you haven't really come to grasp with, then the whole thing can fail, and they'll just say cut back and say, well, let's just go back to the way we're doing it. We knew we could do that. What's much better is to do an incremental migration and to introduce some of these best practices and then change over time. So that in one release cycle you do some improvements, and the next quarter you do other improvements, and so on. And you keep focusing on what is the pain point for you. Because that's one of the things that we have seen is that different teams have different ideas of what microservices is because they have different pain points. They have different drivers. And so then not all microservices are alike even today, but I think it's moved very much beyond just being a buzzword to being something that people are widely implementing.
Okay, thank you. And now a question based on your presentation, Cyrille. You mentioned there, which I really love it. Hack is not a dev, so maybe for you it's new, Peter. You didn't. So if you like, guys, to comment this. I mean, I think you're right, but I'm curious about your perspective. What if you got into trouble by doing something really quick and then try to move it in production and get more issues, and that might make you think twice, or if you got this kind of situations. And I'm sure you got, right? If you put that slide there.
I think it's it was so basically one was I was listing the mistakes we did, and one of them was that we've been hacking a lot, but turning a hack into a production ready stuff there's a no shame between the two.
Yes.
And we've learned that the hard way because it was kind of difficult for us to turn from hacking into delivering production ready software. And I think it's actually the main reason is that we've been hiring people, and just without even noticing, we were just hiring explorers, so guys who can actually hack, be very agile in just discovering a very messy data set and just dig out some patterns and try to use those patterns to make something useful and so on. And those guys are probably not the right person just to make a proper software that you can just ship and just that you can production ready stuff and so on. And I think for now there's probably a cultural shift that we just realized very recently, I would say, that we are not the right person actually to just ship production ready software. And now we are actually like screaming for help actually within the company just to help us actually just getting the right mindset and so on. And that's not about hiring new people actually in that small team, very isolated, and and so on. That's probably more about now having really transversal projects where we could actually hand over parts of that project to other teams and so on. And that's also, we were in quite a, the technical debt was quite heavy in that company and so on. So I've decided actually 2 years ago when I joined to go maverick and to just escape the whole legacy stuff and so on. So now we probably are becoming much more adult, and we try actually to go from the adolescent age into the adult age, and try actually now to go from hacking into.
Just by curiosity, how old is VA?
VA is it was created in 2009.
Oh, okay.
But
So
it's grown very fast and so on, and as always the technical stack was just trying to catch up on the business development, and it was just running behind, as always in fast-growing companies and so on. So business was selling, and the tech had to just follow, and so on. So tech had to deliver on such a pace that they did what every company does, and so on. And now we just are starting dealing with trying to turn the legacy stack into a much more advanced stack.
yeah,
And we can see that problem of tech debt also in a 2 years old team and a 2 years old project. Even in that project now we have such a tech debt that we really need to address that actually properly, I think. Tech debt is actually part of any project, and that is exactly what you were saying. It's about incremental changes rather than restarts from crash. Methodology.
So one thing to add to that, one of the benefits of microservices is that one of the key aspects of microservices is independent deployability. And by having independent deployability, you can upgrade any one of your services without having to redo all the rest of them. And in particular, ideally, without restarting it, the rest, you just upgrade any one service and all the other services keep running. So while you can take incremental improvements, with microservices you can also take big bang improvements, but for say it's just one service. So you can take one service, throw it away, write it in a different language, do it completely differently, and as long as it satisfies the same API and supports the same functionality, then it can go in as a replacement, and you can do it even live potentially if you're brave enough. But the main benefit of microservices is that it gives you that extra ability to take selective big bang approach and just replace components. And replacing small portions of a system is actually a good way to pay back technical debt. Because when you're looking through exploration, you're trying things out. One of the terms is YOLO-driven development. You only live once. And this is useful because a lot of functionality that you think might be useful turns out not to be useful. So you don't necessarily want to invest a huge amount of time in functionality that's never going to be used. But then once it does prove to be useful, you want to be able to make it not only productionized, but stable and robust and reliable. So you can now depend on it, so you can move on and add more functionality. And so then you need some way of stepping through that. And sometimes that's through incremental improvement, sometimes that's through big bang, but you don't want the risk to be overwhelming, you want the risk to be small. And by having a number of many small services, the risk of replacing any one of them becomes a much more manageable risk.
Okay, that's good answers. Okay, so now another question that I'll ask, I see 3 additions. So the question is, we are, getting more advanced in machine learning, artificial intelligence, and so on. So, how long, and at some point, application will start, I don't know, maybe 50 years, 70 years, application will start, we'll not need to write application anymore because they might, write themselves based on speaking, based on, other kind of, provide requirements, and we'll have so much power that we might not actually care so much about, performance and do all the stuff really right, but we'll have, big framework that can do the stuff for us and will not care. So do you think in, I don't know, 70 years, 50 years, we might still need developers? Or, I mean, how do you see this evolution of software development? Because at some point we'll get to the point, you know, it will write itself and will be a kind of singularity that can do all the stuff.
You think that?
Well, if you look at what the job of someone who managed a computer was, or even what the job of a computer, in the 30s, the job of a computer was largely women. Mostly women, and they were human computers. So they would be given tasks to do some mathematical computation, and they would go away and solve it and come back with some solutions. And what happened was that once this started becoming automated, most data centers were run by women because they had traditionally done the computation in the past. So it's only been a much more recent trend from about the 80s onwards that this went into decline, and you see in many organizations in many countries where there's not enough of them. But the history of it is that women used to do it. But not only do you see that, but you see a change in what these roles are. So a big portion of what a developer needed to do was to do things like put all their code on punch cards. And punch cards would have things like each line of code would go on its own card, and they'd all have to be numbered, so in case you dropped the stack of cards, you could put them back in the right order again. I worked with a guy, when he first started programming in Fortran, he had to mail off his program, and then after 2 weeks he would get a printout of all the errors in his program, and then he would have to fix it up on the cards and he would send it off again. So what a developer does has changed dramatically. But the name, to some degree, has only changed a little bit. It used to be more programmers than developers. But the terminology's changed a little bit. Less so than the role of what they actually have to do. So I imagine that the next 20 and 30 years, the sort of work that a developer does today will diminish, and it'll diminish dramatically. But the job of making sure that a computer does what a business person needs it to do, I think that job will still exist. Although what they have to do to make that happen might be quite different. Certainly when I started my career, not only did you do the software, you also had to worry about the hardware. So you were involved in both the software and the hardware as a single part of that job. That's becoming less and less of an issue. Now, instead of having to design the hardware, you're more worried about all the, say, mobile devices you have to be able to support, and how do you test them all and so on. So you've got different considerations. And I certainly think that in 20 years' time, what a developer actually does day to day is going to look quite different to what it is today.